Okay, we're finally here with pointers. I just wanted to make sure we were super comfortable with what an address was before we did that. So a pointer is, let me go back to just a regular old variable again. So I'll say int x equals 10. A pointer is actually a variable that itself stores an address. And so the syntax is the star. So if I say int star x ptr equals and x, what I'm doing is I'm saying that this thing stores an address of x. So I can say printf that p, so that's why it's called p, it's for pointer, x pointer. And what we'll see is this will print out an address. Okay, so that's where x happens to be in memory. Okay. Cool. So I have a variable that stores an address. Now here's something very interesting. If I just say something like this, void modify int x, and I say here x equals 20, so I'll make x different. So x was 10, but let me, before I print x, I will call this method modify x. And now I'll print x. Okay, it's warning me that the variable is unused, but that's fine. Okay, but it prints 10. What gives? I changed it to 20, right? Well, I didn't actually change this one to 20. Remember I told you, when you pass primitive types to a method, it makes copies of them. So I changed the copy to 20, but I didn't change the original to 20. This is why I always tell you to be very careful with changing parameters, because you'll confuse yourself. But here's something else I can do though. I can actually say void modify ref. Instead of passing along x, let me pass along a pointer to x. Okay. And I can actually do something called dereferencing the pointer. And I totally misused and abused this terminology a few weeks ago when we were doing linked list. I really apologize for that. Dereferencing actually means following the arrow to the actual thing. So if I dereference the address 1012 here, I get back 5. Or I get back the location in memory that's 5. So that's what it means to dereference. Okay, so here's the syntax. If I say star x, that is dereferencing x. So now I'm actually at that location in memory, and I can say, at that location in memory, I want you to put a 20. Okay. So if I say modify ref x pointer, and now I go to print x. Let's do that. Now x is 20. So very interesting. So what I did was I passed along a pointer, so the address of x, and I said go to that address, and that's the syntax star x, and change it to 20. That's what this is saying. When you say star a pointer, it's saying go to that address and do your thing. Either take what's out of memory there. So I could say printf, I can say, if I print the pointer, it's that, but then I can printf the integer, and I should get 10 at this point, because I'm passing along a reference to an integer which holds 10. First I'll print out the reference, but then I'll actually print out the value at that reference. So I'm saying go to that location in memory. Now this is a bit confusing the way I've had it written. Maybe I'll call this x pointer just to make sure we're super clear on what's going on here. So this is the address of x. And so I'll print out the address, I'll print in what's in x before. That's saying go there and get it. That's what the star is. And now I say go there and get it, and also do an assignment to that location. And then print the result down here. So what we should see is it should print out the address, then it should print out 10, then it should print out 20. So let's see that. Okay, so there we go. So the address was that. It was 10 when I went to it and looked at it. And then I changed it to 20. Okay, so that's how pointers work. So that's neat. You can actually, the really cool thing about this is you can actually modify multiple variables with a method. So let's say I passed along a couple things. And I wanted to, let's say I wanted to make x 20 and I wanted to make y 40. Who knows why? So I can have a variable y, doesn't matter what it is to start with. I can make it 0. But I'll pass along the address to x, and I'll pass along the address to y as pointers. And now what I should see is it's going to set x to be 20 and y to be 40. So let's look at that real quick. Cool. So this is neat. You can have, this is called passing by reference. You can have a method update variables, and then you can actually look at that result will persist beyond the lifetime of this method. So this is very different from passing parameters like this, where they're copied, and whatever you do here doesn't actually affect what called it. Here, since I'm passing an address, I'm actually modifying, when I dereference here, I'm modifying the same variable in memory. So whatever changes I make here by dereferencing the address, I will be able to notice those changes back here because they're referring to the same thing. Okay, so if I go back to an array, I can see really what an array is a pointer. So when I say int x equals new int 4, so now you can understand this notation a little bit better. What it's saying is this is an address to the beginning of an array. The new says I want you to dynamically allocate an array that has this many elements. So when I was passing along an array, the reason that I saw before when I changed this, it actually, when I modified the array, it actually persisted, is because I wasn't copying the elements of an array. I was passing over an address. So if I say x at index 2 is equal to 5, now you'll see after I say modify ref this array, and I print out x at index 2, let me just put that there to help me. I should see 5, and I do. Okay, so arrays get passed by reference by default because they are a reference. Remember, an array is just a reference to the address at the beginning of a chunk of memory. Remember? So this R actually is just this address here. Okay. Now, if we want to get really fancy, we can do stuff like this. So let me just fill in some numbers here. So I'll say, let me just hard code in some. So I'll say 5, 6, 8, 2, 9. Okay. So if I say printf x, it's going to yell at me because this is a reference, not an actual int, right? But I'm saying to print an int. So I have to change that to a p. A scalar object x requires one element in initializer. Ah, okay. Now let's go back to a moment to this notation. Okay. Anyway, so you see this is an address, right? But if instead I don't say that, I say don't print out x, print out star x. Take a moment and see if you can think, what is that going to print? So there's the array. It's 5, 6, 8, 2, 9. And if I print out star x, it's dereferencing x, which is a pointer to the beginning of an array. So I should see the first element in the array, right? Okay. And now remember, arithmetic done on addresses So x is an address, it's a pointer. That will move me forward by the number of bytes that are in a type. So if I say dereference x plus 2, what that will give me is 8. That's saying, okay, x is the address at the beginning of the array. I want you to go two addresses forward by chunks of an int. And you end up at 8. Okay, so this is a fancy way of indexing an array. You're saying, I want to dereference the address which is 2 ahead of the first address in my array. Okay. So that's how arrays are really working behind the scenes. Okay. And of course, you know, I could go out of bounds. I could say x plus 10. What's that going to give me? Probably something random. Yeah. Okay. Because I'm beyond. I'm at an address in memory that's beyond this chunk. Okay. So I'm going to have you do a quick exercise where you filter an array. So what you're going to do is, and most of the code will be set up for you, but you're going to make a method that returns an array that's a smaller version of the array that you pass it. So it's going to return all the even numbers. It's going to return an array that only contains the even numbers in the array that you pass it. So it'll be smaller because it'll chop out the odd numbers. But I also want you to return by reference the size of the new array. So you can use these pointers to return 2 things. So, you know, for example, I could have this return whatever, but it's also returning a 5 at index 2 here. Or let me make this back. Just imagine this is a regular int again. If I say int x equals whatever, and I say modify int ret equals modify ref the address of x, this will change x to 5, but we also return a -1. So if I say printf x equals, I'm sorry, I needed to say dereferenced x equals 5. So I say x is what, and then the return is what. What I should print is, oops, I needed to put a semicolon. Okay, so I'll say test. Okay, so this is cool. So what I managed to do is this method actually kind of returned 2 things. It returned the -1, which I saved in this variable ret, but it also returned a 5 by reference. So I kind of passed it another variable. I said, I want this to hold something from this method. And so now I can see the result of 2 different things from this method. So that's kind of cool. All right, so I'm going to have you do that in a little exercise. And after that's done, the last thing I want you to do is just verify for me that you're able to compile the audio code, because we're going to do an exercise with it on Friday. All right, enjoy.